So in this lesson, we will derive the general equation of the first law of thermodynamics, considering a control volume. Okay, since we know already the conservation of mass equation, so as I recall, we have that one, the mass of the control volume, over dt plus summation of mass, that is leaving, minus the summation of mass that is entering. This is equal to 0. Okay, so now we are to derive the general equation in the first law. So considering the statement here, we have this cube 1 to 2, and we have this is equivalent to E2 minus E1 plus work 1 and 2. Since you know this equation in our previous discussion, so we take the inexact differential here. So inexact differential of Q with respect to time, of course. So this is E2 minus E1, E2 minus E1. Okay, that one plus exact differential of work over time. Okay, so E2 minus E1, here we have, we have E2 minus E1 with respect to time, an exact differential. Since you know that we have in here E1 is this is E t plus plus that one m I e I. Okay. Okay. Also we have E2. We have Et plus an exact differential of T plus this one, mass ME, and the energy at the exit E. Okay, that is E. So we substituted one in this equation. We have that E2 minus E1. You have E2. So this is Et plus exact differential of T minus Et. Okay, over this one, and this plus mass ME EE minus mass MI EI over exact differential of T. Okay, since we know here that this E is equivalent to U plus V is V squared over 2 plus G times Z, we will substitute this value in here in this equation. Okay, so therefore our E2 minus E1 becomes this is Et plus this one minus E t over here in exact differential of t, this is plus m e, that one, this is u e plus v squared over 2 plus g z. Okay, minus this one, mi over with respect to time plus times u I plus vi squared over 2 plus g zi. Okay, so that one. So you know the work and exact differential of work with respect to time, this is equivalent to the work of the control volume plus the flow work, the delta flow work. That one. Okay, so knowing the equation of work, you have this one. This is equivalent to work at the control volume, and here plus the flow work. This is m e p e v e minus 1 m I p I v I over that one. So we have that flow work. We will substitute based on this equation in here, this one. We will substitute those values considering control volume. Okay, so we have the exact differential of q. We will substitute now those values, so this is equivalent to e t plus the exact differential of t minus e1 over the exact differential of t, that is plus me over t times ue plus ve squared over 2 plus gz. This is minus mi t times this ui plus vi squared over 2 plus gzi plus the work of our control volume with respect to time. Okay, so what do you have in here? So we take the okay, so we have in here an exact differential of q over t plus plus mi time times hi plus vi squared over 2 plus gzi. This is equivalent to E t plus inexact differential of t minus E t here. Okay, that one. This is plus. We have that is plus me over exact differential of t times the quantity he plus ve squared over 2 plus this is squared plus gze plus, of course, the work of our control volume. Okay, so we take the limit here, taking the limit as n exact t approaches to 0. Okay, so we have this limit, the limit of q t as t approaches to 0. This is equivalent to q cv here. So therefore, in our equation we have this one, qcv plus mi hi plus vi squared over 2 plus gzi is equivalent to this one, the energy of the control volume with respect to time, dt plus me he plus ve squared over 2 plus gze plus the work of our control volume. Okay, so this equation therefore is our general equation of the first law. Okay, so we're done. This is the general equation of our first law of thermodynamics. The general equation of the first law for a control volume. For a control volume. Okay, and thank you for watching. See you on the next video.